Okay, we're back, still talking about Unit Electricity 07 with series and parallel circuits. I'm going to scroll through all of this though because we covered this in the review video, and we are going to talk about series circuits with multiple resistors and how to calculate the resistance, the volts, and the amps in a series circuit. So again, a series circuit, the components are connected along a single path. The same current flows through all components. So our current will be consistent through all of the components. Again, there's only one path for that current to flow. The total voltage is shared between all of the components. So for example, if we are using a 12-volt battery and we've got 6 lights in our circuit, 2 volts will be designated for each light. So voltage of all the lights equals the total voltage of the circuit. So down below, if we look at this, we've got 12 volts, we've got 3 lights. We know that we will have 4 volts for each of these components if this was our actual circuit. The advantages of a series circuit is that it's easy to set up. It's a simple design. There's only one path for electricity to flow, and it's easy to fix. If we have a lamp burn out, we can easily figure out what lamp we need to replace. The disadvantages of a series circuit: the circuit will not work if it's broken or disconnected wires. For example, if you think about a Christmas tree lights. If we have all of those lights and one of them burns out, the entire string of lights will go out. Not so much anymore because they've fixed that kind of problem with probably putting some parallel wiring in those lights. So now we can have one light burn out. But if you think about maybe when you guys were little, okay, if one light went out, the entire light would go out. That would have been an example of a series circuit. So when we look at a series circuit, in this situation, we have got a circuit that has 3 resistors. We have one that's 2 kiloohms, 2 kiloohms, and 2 kiloohms, and we're using a 12-volt battery. I know it's a battery because of the symbol that's being used with the plus and the minus. In a series circuit, the total resistance, and we show this as R total, equals the sum of all resistors. We have got 2 plus 2 plus 2 gives us a total resistance of this series circuit of 6 kiloohms. Voltage drop. As current flows along each resistor or bulb, it uses up some energy. So each bulb creates a separate voltage drop. So voltage basically goes down after each resistor. So when current and voltage are flowing through a series circuit and it hits the first lamp, the voltage is going to decrease. We call that a voltage drop. If we know the current and resistance, we can calculate the voltage drop using Ohm's law. So how to calculate the voltage drop? Again, we know that voltage drop across each resistor equals the current through the resistor times the resistance of one of those resistors. So first, if we're looking at this series circuit right here, we know that we've got 100 ohms of resistance, 300 ohms of resistance, and 50 ohms of resistance for resistor 1, resistor 2, and resistor 3. We are using a 9-volt battery. So let's go ahead and first find the current. I equals V divided by R. So we know that volts divided by R. Which R? What we need to do is add them up. So in this situation, we have 450 ohms of resistance. So 9 volts divided by 450 ohms of resistance gives us a current of 0.02 amps. Next, what we need to do is find the voltage drop for each resistor. To do that, we're going to use Ohm's law, which states that volts equals current times resistance. Sorry, a little zealous with my clicking there. R1, to find the voltage drop for R1, We're going to take the current, which we know we calculated to be 0.02. We're going to multiply it by the 100 ohms of resistance for R1, resistor 1, and that gives us a voltage drop of 2 volts. For resistor 2, we know that current is 0.02 amps. We have 300 ohms of resistance, so our voltage drop for resistor 2 is 6 volts. And resistor 3, again, we know current is 0.02 amps. We know that we have 50 ohms of resistance. 0.02 times the 50 ohms gives us 1 volt. The way to check this is we want to see if our voltage drop totals our voltage producer, right? So we know that we've got 9 volts running through this series circuit. If we add 6 plus 2 plus 1, we get 9. So we know that we've calculated our voltage drop correctly. Again, does the sum of all voltage drops total the total voltage? Yes, it does. So we have done that correctly. So let's practice. We have an example here where we've got 6 volts of a battery. We've got 2 resistors. Both of them are 1 ohms of resistance. We know the Ohm's law of V equals I times R. So what is the voltage drop across the bulbs? What is the one thing that we're missing here? We're missing current, aren't we? We know that we've got 6 volts and we've got 2 ohms of resistance if we add up each resistor. So we need to find our current. So, it's actually what is the total voltage across the bulbs? We know that that's 3, right? Because it splits up. So we've got 3 volts here and 3 volts here, which total 6. What is the total resistance of the circuit? 2 ohms. 1 plus 1 is 2. What is the voltage drop across each light bulb? So again, here's where we need to find the current. And the current is going to be 3 amps. We've got 6 volts divided by 2 ohms of resistance gives us 3 amps. The voltage drop for R1 is 3 amps times 1 ohm of resistance gives us 3 volts. The voltage drop for R2 is the same because we have 1 ohm of resistance. So we've got 3 amps, we're going to multiply it by 1 ohm, and that gives us 3 volts. Let's check ourselves. 3 volts plus 3 volts gives us a total of 6 volts. Let's practice another one. Our resistors are different ohms. Okay, so what is the total resistance of the circuit? If you said 6 ohms, you are correct. 2 plus 3 plus 1 is 6 ohms. What is the current of the circuit? We know that we can use Ohm's law to figure out that current. If we have 9 volts and we've got 6 ohms of resistance, our current is going to be 1.5 amps. 9 volts divided by 6 ohms of resistance gives a total current in the circuit of 1.5 amps. What is the voltage across the bulbs? We have 3 bulbs. What is our voltage across those? The answer would be 3 volts because 3 times 3 equals 9. What is the voltage drop across each resistor? So now what we need to do is figure out the voltage drop for each resistor. So let's call this, I can't see my mouse anymore. Let's call this resistor 1, resistor 2, and resistor 3. So the voltage drop for resistor 1 is 1.5 amps times our 2 ohms, and that equals 3 volts. We have a voltage drop for resistor 1 of 3 volts. The voltage drop for R2 is 1.5 amps times 3 ohms of resistance, and we get 4.5 volts of voltage drop in resistor 2. Resistor 3, again, we've got 1.5 amps times the 1 volt of resistance, 1 ohm of resistance, sorry about that, and that gives us a voltage drop of 1.5 volts. Does the sum of the voltage drops equal the total voltage? 3 plus 4.5 plus 1.5 does equal 9. So we are correct. Our next unit is going to be parallel circuits. I'm going to stop the video here, and I will do a separate video for parallel circuits.